In this video, we're going to explore the large functional group category known as carbonyls. A carbonyl group contains a C double bond O somewhere in the molecule. When we look at the shape of this, the molecular shape around that carbonyl carbon is trigonoplanar. And of the two other groups attached to that carbonyl carbon, in most cases, one of them is an R group, some other carbon group, and the other group attached to that carbon identifies what type of functional group it is. And so let's take a look at those different types. In the first type, we have, as in all of them, some sort of R group, and so this group could be anything in any of these molecules. But the other group attached to that carbonyl carbon is a hydrogen. This type of compound is known as an aldehyde. If that other group attached to the carbonyl carbon is another carbon group, another R group, then we call that a ketone. If it is an OH, an alcohol attached to that carbonyl carbon, that's a carboxylic acid. If we have an oxygen attached to another R group coming off our carbonyl carbon, that's known as an ester. You can see that this looks sort of like an ether, only off one of the carbons we have that C double bond O. That's a classic trait of the carbonyl group. And if we have a nitrogen attached to that carbonyl carbon, we have an amide. So in other words, another way to think of an amide is that we have some sort of amine which is attached to a carbonyl. And so these are the 5 different types of carbonyls. In this class, CHY 107, I'm not going to hold you responsible for naming of carbonyls in the same way that you would be responsible for naming other functional groups that we've looked at. However, we're just going to look at some examples of some different types, and we will look at what the naming conventions are, because you will be expected to be able to identify any of the different types of carbonyls based on either looking at the compound and seeing what is attached, or by seeing the name and knowing what the naming convention is and recognizing it that way. And so the first group, aldehydes, we can see 3 different aldehydes here. The key part in aldehyde naming is recognizing the AL at the end of the name. So our suffix for aldehydes is AL. And again, structurally, we would recognize these as aldehydes because coming off our carbonyl carbon, which is the carbon that makes up the C double bond O, we have what is not drawn in, but we have a hydrogen. We do see the hydrogen written in here. Then in this case here, we have a hydrogen as well. And so we know that these are aldehydes, both because of the hydrogen coming off our carbonyl carbon, and because all of the names end in AL. In our next group, ketones, our structure again is characterized by having another R group coming off our carbonyl carbon. Our names are categorized by all ending with O-N-E, pronounced own. And so these would be recognized by having that ending for the name, such as our first one, heptan 2-one. Our next group of carbonyls, carboxylic acids, are characterized by having an OH coming off of our carbonyl carbon. The names are categorized by ending in oic acid, such as in hexanoic acid here, or 2-ethyl hexanoic acid, or this one here, 2-butyl-5-ethyl octanoic acid. And so we recognize them again structurally by having an OH off our carbonyl carbon, and name-wise they end in oic acid. Something to be aware of is that if you are looking at a structure of a compound written out, for instance, if you see a formula CH3COOH, COOH is quite often an abbreviation that is used to signify that is a carboxylic acid. So that is something to be aware of going forward. And so this one here, the CH3COOH, would look like this. We have our CH3COOH. So just be aware of that if you are looking at other sources that use the COOH abbreviation for a carboxylic acid. And then we come to esters. So remember, esters look similar to ethers in that we have an oxygen combined with two different R groups on either side. But in the case of esters, one of those R groups is our carbonyl, our C double bond O. And so that's how we recognize esters structurally. Oxygen connected to our carbonyl. The names of esters all end with O8. So any compound you see ending with the suffix O8, you know is an ester. The last carbonyl compounds that we looked at were amides. Recall that amides are very similar to amines, only now one of our R groups coming off of the amine is our carbonyl with our C double bond O. And so structurally we recognize amides as some sort of nitrogen containing compound coming off of our carbonyl. The naming of amides is pretty much the exact same as the naming of amines, only now our ending will be amide or amide. So this video has provided a brief overview of our carbonyl containing functional groups. Remember that in this course I will not hold you responsible for being able to name individual carbonyl compounds. However, you would be expected to be able to tell what type of carbonyl it is, given either the structure or the name. In other words, I should be able to give you the name N-methylhexanamide, and you would know that it is an amide compound. Or I should be able to give you this structure right here, and you would recognize that it is an amide based on that structure. I hope this video has been helpful. Be sure to come see me if you do need some additional assistance.